now let's take a look at adding and subtracting fractions with unlike denominators. So when it's unlike, we have to do a little bit more work. So for example, method 1, we want to multiply the numerator and denominator of each fraction by the denominator of the other fraction. So for example here, we have 1 over 8 plus 5 over 6. One way to do this is that we can multiply by the denominator of the other. So on the right, I'm going to multiply by 8 over 8. On the left, I'm going to multiply by 6 over 6. Now it has to be that because you don't want to change the number completely. You're just multiplying by a form of 1, which doesn't change it. So 6 times 1 is 6 over 8 times 6, which is 48, plus 5 times 8 is 40 over 6 times 8, which is 48. And so now we can add across. So this is 46 over 48. And then if we simplify this a little bit more, we can divide 2 into the numerator and denominator. And so, or we can factor it. So this is 2 times 23 over 2 times 24. And then we notice that we can cancel out the common 2's. And now we're left with 23 over 24. So that's one way to do that problem. The other method is to use the least common denominator, or the LCD. The LCD of 2 or more fractions is the least common multiple of the denominators. Now, to talk about the least common multiple a little bit more, the least common multiple is the product of the highest power of each factor that appears in any expression. So product means to multiply highest power. And so let's take a look at this example here. We have, so I want to go back and do 1 over 8 plus 5 over 6. So let's do that. 1 over 8 and 5 over 6. Now I want to do it with method 2. So 1 over 8 plus 5 over 6. Now I know this is going to be a little complicated in how we're going to do this, but it does kind of shorten what we're doing. And the other part of it is when we're looking at expressions later on in the next lesson, it will really help us out in why do we multiply by certain values. And so we have 1 over 8 plus 5 over 6. Now what I'm going to do is I'm going to factor each one. So factor each denominator, 8 and 6. 8, we know it's 4 times 2, or 2 times 2 times 2. So let's write that as 2 to the third power. 6 is 2 times 3. Now when we're looking at lowest common multiple, again, it's the product of the highest power of each factor. So this value here in this expression, so this value here is 8. We have a 2 cubed here, and in 6 we have 2 times 3. So what we're taking is the highest power, and so we're going to take 2 cubed. So since we have 2 cubed and 2, we only take one of them. We're only taking the 2 cubed. So let's write that, 2 cubed. Then there's only a single 3 here, so I have to take that one. Okay, we'll get some more practice on this in a little bit. So we're really looking at 2 cubed is 8 times 3, which is 24. So we want to have an LCM of 24 here. And we have 8 times 3 is what makes it. So if we take a look at this 8 here, in order to make it 24, we're missing a single 3. So we're going to multiply the top and the bottom by a single 3. Now we have 5 times 6. As we said, 5 times 6 was 2 times 3. And so we see we have a 2 cubed here. So what are we missing in this 2 times 3? Well, we need another 2 times 2, right? We have only a single 2 here. We're missing a 2 squared. So we're missing a 2 squared, which is a 4, correct? So, and remember, 4 times 6 is 24. Now look what happens. 3 times 1 is 3, plus 5 times 2 squared, that's 5 times 4, is 20. And the denominator is the common denominator of 24. So this is 23 over 24. So when we multiply by the lowest common multiple for the denominators, or the lowest common denominator, we have less work that we need to do. Now initially it seems like a lot of work, especially because this is probably new and how we're rewriting it, but it does help us in the long run. So let's try this example here. So I'm going to try a couple of examples for us. We have 23 over 4 minus 17 over 10. So 4, that's 2 times 2, or really that's 2 squared. Then when we factor 10, that's just 2 times 5. LCM again is the product of the highest power of each expression. So let's look at these examples here. We have 2 squared and 2 times 5. So which one are we going to take? The 2 squared or the 2? Which one is the highest power? Remember, that's 2 to the first. So we're going to take 2 squared. So 2 squared we're taking, so we can ignore this 2. Then we have 5, and so we have to take 5. So we took 2 squared and 5. 2 squared times 5, that's 4 times 5 is 20. And so now we need to multiply that to our unlike denominators here. So we have, in order to make 20 in the denominator, looking at our LCM, we're missing multiplying by 5. 5 times 4 is 20. Then for the 10, we're missing a 2, right? That makes it 20 there. So 23 times 5 is 115, minus 17 times 2 is 34 over 20. And then so we're left with 81 over 20. Now, sometimes you don't have a choice but to use method 1 because there is no other common factors. So, for example, number 2, that has to be method 1. You're going to multiply both by the other denominator. So this one you would multiply by 5 over 5, and this one 7 over 7. Now, 4 and 6, let's try that out one more time with 4 and 6. So 4 is really 2 squared. 6 is going to be 2 times 3. Now I want the highest power of each expression. So looking at the 2's, I'm going to take the 2 squared, and then, so I'm going to call it LCM, or LCD. So I'm going to take 2 squared, and then I have to take this 3. So this is 4 times 3, which is 12. And so instead of multiplying this denominator by 6 and this one by 4, I only need to multiply in order to make 12. So to make 12 over on the left side for the 4, I'm missing only a 3, right? 2 squared times 3 would be 12. And then 6 is 2 times 3. Notice I am only missing a single 2, so multiply by 2. So now we multiply. 3 times 3 is 9, and then over 12 minus 2 times 1 is 2 over 12. So this ends up being 7 over 12.